Hello everyone, welcome to AJJ Engineering. Today I would like to discuss with you the types of metals. The metals that steelworkers work with are divided into two general classifications, that is ferrous and non-ferrous. Ferrous metals. Ferrous metals include all forms of iron and steel alloys. A few examples include wrought iron, cast iron, carbon steels, alloy steels, and tool steels. Ferrous metals are iron-based alloys with small percentage of carbon and other elements added to achieve desirable properties. Normally, ferrous metals are magnetic. The following are the different types of iron and steel that can be made from iron ore. Pig iron. Pig iron is composed of about 93% of iron, 3% to 5% of carbon, and various amount of other elements. Pig iron is comparatively weak and brittle, therefore it has a limited use and approximately 90% produced is refined to produce steel. Wrought iron. Wrought iron is made from pig iron with some slag mixed in during manufacture. Almost pure iron. The presence of slag enables wrought iron to resist corrosion and oxidations. The chemical analysis of wrought iron and mild steel are just about the same. The difference came from the properties controlled during the manufacturing process. Wrought iron can be gas and arc welded, machined, plated, and easily formed. However, it has a low hardness and low fatigue strength. Cast iron. Cast iron is any iron containing greater than 2% carbon alloy. Cast iron has a high compressive strength and good wear resistance. However, it lacks ductility, malleability, and impact strength. Alloying it with nickel, chromium, molybdenum, silicon, or vanadium improves toughness, tensile strength, and hardness. A malleable cast iron is produced through easily as the low carbon steels. They are used for crane, prolonged annealing process, hooks, axles, shafts, set screws, and so on. Ingot iron. Ingot iron is a commercial pure iron, 99.85% of iron, that is easily formed and processed, good ductility and corrosion resistance. The chemical analysis and properties of this iron and the lowest carbon steels are practically the same. The lowest carbon steel, known as dead soft, has about 0.06% more carbon than ingot iron. In iron, the carbon content is considered an impurity and in steel it is considered as an alloying element. The primary use for ingot iron is for galvanized and enameled steel. All the different metals and materials that we are in our trade, steel is by far the most important. Steel is manufactured from pig iron by decreasing the amount of carbon and other impurities and adding specific amount of alloying elements. Pure iron has less than 0.15% of carbon. In steel manufacturing, controlled amount of alloying elements are added during the molten stages to produce the desired composition. Carbon steel is a term applied to a broad range of steels that falls between the commercially pure ingot iron and the cast iron. This range of carbon steels may be classified into four groups. 1. High carbon steels or very high carbon steels. 2. Low alloy, high strength, tempered structural steel. 3. Stainless steel. 4. Austenitic steel. High carbon steel or very high carbon steel. Steel in these classes responds well to heat treatment and can be welded. When welding, special electrodes must be used along with preheating and stress relieving procedure to prevent cracks in the welded area. These steels are used for dies, cutting tools, mill tools, railroad car wheels, chisels, knives, and so on. Low alloy, high strength, tempered steel. A special low carbon steel containing small amount of alloying elements that is quenched and tempered to get a yield strength of greater than 50,000 psi and a tensile strength of 70,000 to 1,20,000 psi. Structural members made from these high strength steels may have smaller cross sectional areas than common structural steels and still have equal or greater strength. Additionally, these steels are normally more corrosion and abrasion resistant. Stainless steel. This type of steel is classified by the ASI into two general series named 200 to 300 series and 400 series. Each series includes several types of steels with different characteristics. The 200-300 series of stainless steel is known as austenitic steel. This type of steel is very tough and ductile in the as welded condition. Therefore, it is ideal for welding and requires no annealing under normal atmospheric conditions. The most well-known types of steels in this series are the 302 and 304. They are commonly called 18 to 8 because they are composed of 18% chromium and 8% nickel. Low carbon steel, 0.05% to 0.3% of carbon, are most widely used, normally non-magnetic. Medium carbon steel, 0.35% to 0.45% of carbon. High carbon steel, 0.45% to 0.75% of carbon. Their crystalline structure into two general groups. One, very high carbon steel, that is 0.75% to 1.70% carbon groups, is known as ferritic chromium and the other group as martensitic chromium. Alloy steel. Steels that desire their properties primarily from the presence of alloying elements other than carbon are called alloys or alloy steels. Among the more common alloying elements are nickel, chromium, vanadium, silicon, and tungsten. One or more of these elements may be added to steels during the manufacturing process to produce a desired characteristic. Alloy steels may be produced in structural sections, sheets, plates, and bars for use in the as rolled conditions. Better physical properties are obtained with these steels than the possible with hot. Some of the common alloy steels are briefly described in the paragraphs below. Nickel steel. These steels contain from 3.5% nickel to 5% nickel. The nickel increases strength and toughness of the steels. Nickel steels containing more than 5% nickel has an increased resistance to corrosion at scale. Nickel steel is used in the manufacture of aircraft parts such as propellers and airframe support members. Chromium steel. These steels have chromium added to improve hardening ability, wear resistance, and strength. These steels contain between 0.2% to 0.75% of chromium and 0.45% of carbon or more. Some of these steels are so highly resistant to wear that are used for races and balls in anti-friction bearings. Chromium steels are highly resistant to corrosion and to scale. Chrome vanadium steel. These steels has the maximum amount of strength with the least amount of weight. Steels of this type containing from 0.15% to 0.25% of vanadium, 0.6 to 1.5% of chromium, and 0.1 to 0.6% of carbon. Common uses are for crankshafts, gears, axles, and other items that require high strength. These steels is also used in the manufacture of high quality hand tools such as wrenches and sockets. Tungsten steel. This is a specially alloy that has the property of red hardness. This is the ability to continue to cut after it becomes red hot. A good grade of these steels contain from 13% to 90% of tungsten, 1% to 2% of vanadium, 3% to 5% of chromium, and 0.6 to 0.8% of carbon. Because of this alloy is expensive to produce. Its use is largely restricted to the manufacture of drills, lathe tools, milling cutters, and similar cutting tools. Molybdenum. This is often used as an alloying agent for steel in combination with chromium and nickel. The molybdenum adds toughness to the steel. It can be used in place of tungsten to make the cheaper grades of high-speed steels and in carbon molybdenum high-pressure tubing. Manganese steels. The amount of manganese used depends upon the properties desired in the finished product. Small amount of manganese produce strong, free-aging steels. Larger amounts between 2% to 10% produce a somewhat brittle steel, while still larger amount 11% to 14% produce a steel that is tough and very resistant to wear after proper heat treatment. Non-ferrous metals. Non-ferrous metals contain either no iron or only insignificant amount used as an alloy. Some of the more common non-ferrous metals steel workers work with are as follows: copper, brass, bronze, copper nickel alloy, lead, zinc, tin, aluminum, and duralumin. Carbon steels. Carbon steels are the iron carbon alloy containing up to 2.06% of carbon, up to 1.65% of manganese, up to 0.5% of silicon and sulfur and phosphorus as impurities. Carbon content in carbon steels determines its strength and ductility. The higher carbon content, the higher steel strength, and the lower its ductility. According to the steel classification, there are following groups of carbon steels. 1. Low carbon steels. Carbon less than 0.25%. Properties: good formability and weldability, low strength, low cost. Applications: deep drawing parts, chain, pipes, wire, nail, and some machine parts. 2. Medium carbon steels. Carbon percentage 0.25% to 0.55%. Properties: good toughness and ductility. Relatively good strength, may be hardened by quenching. Applications: rolls, axles, screws, cylinders, crankshaft, heat treatment machine parts. High carbon steels. Carbon greater than 0.55%. Properties: high strength, hardness, and wear resistance, moderate ductility. Application: rolling mills, rope wire, screwdrivers, hammers, band saws. 4. Tool carbon steels. Carbon greater than 0.8%. Properties: very high strength, hardness, and wear resistance, poor weldability, low ductility. Applications: punches, shear blades, springs, milling cutters, knives, razors.